We've seen in the past many errors that come up when we run our programs, and we've talked about some ways to prevent errors or debug errors when they occur. But one other tool that's available to you is exception handling using the try and except structure in Python. So exception handling generally means telling your program how to handle errors that come up as the program is running. So the error has already occurred, but the program doesn't just crash. It actually responds and reacts in some way, giving a message to the user that something went wrong, trying again to see if it's possible to recover from the situation. Lots of different possibilities of what you might do. But it's once the error has already happened. You already tried to index into a list with an invalid index, or you already tried to divide by 0, or that kind of thing. This is especially helpful for errors that you can't detect, or that it would take many more lines of code to try to detect the error than it might take to just handle that the error has happened. So, for instance, files can be very prone to errors because, one, someone might give us a file name that doesn't exist in the first place, and then we attempt to open it and an error happens. Now, there are technically ways to check whether a file exists, so we could do that, but there's nothing stopping the operating system from deleting the file the moment after we checked that it does exist. In some operating systems, it may not even stop deleting the file if we are in the middle of reading it. It's similar for network connections. We might lose a network connection while we're trying to communicate over it, and that can cause errors in our program. Lots of other different possibilities, and we might also just find ourselves in a situation where there are so many possible ways that something could go wrong that it might be easier just to say, you know what, if this goes wrong, here's how to handle it. So exception handling allows you to write code that might do something more helpful for users than just crash and print out those stack traces that can even be challenging for programmers to understand, let alone our users. So let's look at a specific example of some code that might have some errors in it. This is a good chance for you to reflect on what actually could go wrong in a program and think about which things are reasonable to check in advance and which things might just be easier to let the error happen and then respond to the error in that situation. So this is a quadratic equation function. It plugs in the a, b, and c from a quadratic equation. You may remember that the form of a quadratic equation is ax squared plus bx plus c. And we can take those three values and use the quadratic formula to get the solutions for that particular quadratic equation. It requires doing the square root of some combination of those a's, b's, and c's, and then doing a division by 2 times a. And we'll come away with 2 answers, and we return those in this case as a list. We could have returned them as a tuple or as a string that contains the 2 answers. That's not really relevant to the design we're thinking about here because we want to think about what errors are possible. So if you have the time, pause the video for a moment, think about the mathematical operations that are happening here and the different things being done, and what kind of errors you've seen before that might come up here. At least 2 things mathematically that we know can happen when we are plugging things into the quadratic formula is issues with the square root and issues with the division. if 4 times a times c is larger than b squared, then we'll be doing the square root of a negative number. And when you and I are solving through, we might notice that, pause our calculations and say, this is going to be imaginary. Am I required to calculate what the imaginary roots are? Well, the square root function in the math library in Python doesn't do that. It will just cause errors if you give it a negative number and ask for the square root. And similarly, division, we cannot divide by 0. So if a is 0, which is not a real quadratic equation in the first place, but leaving that aside, if a was inputted as 0, then we have another situation where an error could occur in our program. These are both ones that we could relatively easily detect if we wanted to in advance, but we're going to handle them by exception handling in this case. And one other thing to take into consideration is bigger scope issues that we might not even really think are reasonable, but that we still don't want our program to crash. For example, if the user inputted the string, quote, 2 as A, or the string, quote, 11 as C, then when we go to do our multiplications, our subtractions, our divisions, our square root, at some point in there, the program is going to have problems because we can't multiply a number like 4 times a string or things like that. So if the data is of the wrong type, that might also cause us problems that would cause our program to crash normally. If you're not sure of what kinds of problems might come up, this is a really good case for testing, thinking through what are good values and what might be weird or unreasonable values, but testing what happens in your code. That does you 2 favors. 1, it confirms that your code works well when the values are good. And 2, it shows you what are the exact types of errors that are going to get created when this program runs. And that will be important here when we look at things a little more specifically in a moment. First, let's look at the try and except structure. So we have a try keyword and a colon, and then some code in there. This would be code that we suspect might generate errors sometimes, but we don't have the ability or don't find it as useful to check with if statements every single possible error that might arise there. Then after we're finished with the try portion, we write an except portion. We may or may not specify the type of error that we're trying to handle. But regardless, if an error comes up, if it's of the correct type, if we've specified the type, or just if in general an error comes up, then we'll land in the except portion. And that's where we could print an error message to the user, attempt to recreate a file that was deleted while we were trying to work on it, or restart the program because everything went so wrong that we don't know what to do, so we can go back to the beginning of what we're going to do. Something that would actually be a graceful way to handle the problem that's arisen. And so let's go back to this idea of specifying the error type. It is usually best practice to specify a particular type of error that you know might happen. If you just do try and except with no error type specified, you're not going to be able to tell the user meaningful information about what went wrong, as in, you gave me an index that was out of bounds. But if you say that your exception is for index out of bounds errors, then you can tell the user that. The other issue is you will not be able to figure out how to recover from the error, and so the underlying conditions that were wrong and bad, such as negative numbers where you tried to do a square root, those might persist, and you might continue trying to work with those bad values later on in your program. So handling a specific type of exception helps you to have more information. Let's see how that's done. So here's one kind of error that we talked about could arise with the quadratics program. So we know that this function is prone to errors in these parts, where we're doing the square root and the division and so on. We could even break it down more, but it's probably best to just keep this all as one chunk, and we'll see why in a moment. Let's handle just the value error, which is to say when we can't do the square root. If we try to take the square root of a negative, you will find that Python throws a value error. So what we can do is just tell the user, hey, you gave me negatives and that's fine. Or I'm sorry, you gave me numbers that come out to negatives for when I'm trying to do the square root, and that's fine. You didn't do anything wrong. There just are no real roots for this particular problem. So that's useful information to the user. This is also where we could try to handle the imaginary case if we wanted to, but our program is not going to do that because we don't have time to work all the way through that. So that handles one kind of error. This program, however, would still crash if the user gave us 0 as the value for a, because we would be doing division by 0. So we could add another type of error. I'm sorry. We're actually going to handle when the user gives us things that are not numbers for a, b, and c here. So if the user gave us something like 2, 2, and then quotes 11, or if all of them were strings, they just typed in and we took the user input. Another example of where this could commonly come about is if you were accepting those numbers as user input. Remember that that input comes in as strings, and at some point in your program you might have forgotten to convert those strings to integers. And so they may have given you the number 2 and the number 2 and the number 11, and you might have forgotten that, the input function gives me strings. I need to convert those to integers when I want to solve this equation. So if they gave you something, or if your function was called with something other than numbers, when you go to do things like the subtraction or the multiplication or things like that, then you'll get type errors. And so here we report to the user that they were supposed to give us numbers. They didn't give us numbers. That's not great. So now, division by 0. So you can see we're handling these specific types of errors, each with their own section, so that we can give meaningful information to the user. So when there's a 0 division error, then we'll tell the user that they tried to divide by 0. You might even give them further information and say, a was 0, this is not a real quadratic, or something like that. Then down at the bottom, you can see that we did actually include one more except statement with no error type specified. This is sometimes okay to do and sometimes bad practice, and you really just need to sort of use your own judgment for this. So here we're just telling them something else went wrong. I don't know what. I didn't anticipate this kind of error, and somehow it's gone wrong in a way that I didn't expect. Now, the reason that this is sometimes bad practice is, as I mentioned before, you might be allowing some problem to persist in your program that you can't figure out. And this is where you've probably seen programs before on your computer that you were running that they just go error message, error message, error message, error message over and over because they've hit some state where something went wrong and it couldn't be recovered from. And the program continues running. Sometimes it's best if there's such a bad error that we didn't even anticipate it, just to let the program crash, show the stack trace, and the user could then go to your website and file a bug report or email the tech support people for help or something like that. Because if it's such a strange error that even your programmers didn't anticipate it, it might require that level of attention. This is something unique to, say, the particular hardware that user is on or something like that. And probably it's better to do that than to just repeatedly say, for instance, something went wrong. That's not much helpful information. You can, in more advanced ways, catch the exception and create a variable that represents the exception object, the exception thing that happened there, and then you could print out the stack trace or print out what type of error it was or that kind of thing. So if you're going to write a general one like that, it's best to look up how you can actually have the exception as a variable and to share some of the information about it. But for our purposes here, we're mostly going to be dealing with simple error types that we've seen and we know at least a little bit to anticipate them, not some strange, obscure one that's based on what type of hardware the user was using or something like that. One other way that exceptions can be a tool is that you actually can raise them. So as an example that we've seen in the code we were looking at here, the square root function somewhere inside of the function notices that a negative number was given, and it actually raises a value error. It creates an error of its own and raises it. Sometimes these fit into existing categories, and sometimes we define our own types of categories. So, for instance, if you were writing a game and you asked the user to input a character name, like for their character in the game, and the user used some symbol in that they're not allowed to, or they used a curse word and this is a game for kids and you want to disallow that, or that sort of thing, you actually can raise your own errors. You could raise a value error in that example and signify to another part of the program, hey, an incorrect value was given there. Could you please ask the user to try again and give a different value for their character name? That will require either the part of the code that is getting that error to have a try and accept block there to handle it, or it will cause the program to crash and show a stack trace. But it can be a good idea to raise these kinds of errors to see that something went wrong earlier on. Again, I mentioned the programs that crash that just say something went wrong, some generic error over and over again. That's not as helpful. So in some cases, you might raise an error and you can actually provide an error message with it. So there you can provide a string that will be printed out when that error is raised if it's not caught, if there isn't a try and accept around it. And so you can create functions or sections of code of whatever type that generate their own errors to indicate something is wrong in a way that I don't have a clear recovery for it, and I'd rather just tell you something is wrong. If you're ever curious about what types of errors you might need to catch, by the way, you can look in the Python documentation for the different function calls you're doing. For instance, if you looked up the math library and looked at square root, it might well have a note in there that says raises a value error when given a negative number or something like that. So if we had looked back at that previous code and we weren't sure what kinds of errors might occur, we could look up that square root does raise errors, and here's one of the types of errors that it raises. So you can often use references for that. One last note is that exceptions are one type of tool for handling one category of errors. These are runtime errors, meaning errors that happen as your program is running and that actually generate exceptions. Exceptions are not for handling syntax errors in your code, like you forgot to type a colon after or at the end of your if statements line, or things like that. And they're also not for handling code that runs without exceptions being generated but produces the wrong output. Say your program doesn't quite give you the full string that you expected it to. Well, exceptions won't come up from that. You'll just get the string and it'll be missing the period at the end of the sentence or whatever. And it's usually not a good idea to try to raise exceptions to handle those situations. It's better to use tests that will check before you release your code and before you use it somewhere else whether output from that code is right or wrong. And it's usually best to examine the logic of the code, because those kinds of problems are logic errors. They are not runtime exception generating errors. So there are lots of different kinds of errors that you may have to handle. Exceptions and exception handling is really only one category of those. They're a certain set in which you've sort of violated some rules of the language or of a function that you are using, but not rules within like how to write the code, syntax, or rules of how you want the program to perform, like always coming out with positive answers for this kind of question, or that sort of thing. Those you have to handle and solve in other ways. So exceptions are a really useful tool for handling problems, handling errors once they've arisen in your code. They can be especially useful for errors that you would not have been able to detect or prevent, but they can also be useful just for handling an error that it might have been more overhead or more complex coding to check for it in advance, and sometimes you just catch the exception that might have arisen in that situation. We could check all of the possible types that our data, the parameters to our function could be, or we could catch a type error or type exception or type error as an exception and just handle that in a small portion of code. They are very useful if you know what kinds might arise from particular parts of your code, and you can then respond in a specific way that notifies the user or that recovers from that particular error. It's not as useful to generically catch all exceptions and have very vague error messages that don't tell people how to fix things. And exceptions also can't be used to handle every single possible type of error that might come about when writing your code or when running your program. And you'll learn more about those as you get more experience.